The science of Hello everyone, welcome to this video. In this video I'll be reacting to one of the early uploads from the YouTube channel The Game Theorists. I'm a huge fan of their work and I hope that you like this video as well. This video is about 4 years ago, because 3 years ago. So it's from 2018, I remember. So let's start.
Dear Bennett Foddy, dude, just get out. Get out now. Just go. Go! Because you know what? I take back what I said on Twitter. I take back saying that I don't get mad.
Am I the only one who gets mad playing Get Over It? I mean, I suck at it, but I don't get mad.
At playing Getting Over It. Because you know what? You know what, Foddy? I am freaking mad! This was supposed to be a simple episode about levers. I chose to do a simple episode because, well, while this is coming out, who knows when?
The science of of a simple episode. Very interesting. I don't think it's ever simple.
And I'm working on this right before Christmas, and my last topic, the one on the economics of Cuphead, fell through. Normally, I'd feel bad about that, but since the topic seemed capable of confusing even Nobel Prize winner and father of behavioral economics Richard Thaler, I'm gonna give myself a pass.
Maybe.
Do an episode on Getting Over It, I told myself. Why not? Something easy before the year is over.
Did he just mention something easy?
Just a basic forces in, forces out, big numbers on screen, yell a little, and rake in that sweet, sweet YouTube money.
Come on.
Was I wrong? Oh God, was I wrong? And I have to say, it brings me great pleasure. Oh, the greatest pleasure to say, Getting Over It makes none, not a single goddamn sense. But before I continue,
And now a message from the sponsors.
I'd like to bring you a message from this episode's sponsors. This week's science is brought to you by Single Malt Cask Strength Arbalor, Maximum Strength Ibuprofen, Ranitidine 75 milligrams, Calcium Carbonate, and Sertraline.
That's really, really specific. Huh. Why?
Biochemistry, keeping Austin's body and mind functioning just enough to keep the constant churn of content churning.
He just mentioned just enough.
Getting Over It, for those of you who don't know, is the latest outrage machine developed by Bennett Foddy, the
Outrage machine.
dude who made Quap, as if we needed another memey thing that just made us mad. Getting Over It is an unapologetic exploration of uncompromising game design, but what it mostly is freaking hard. From Foddy's own mouth, it is an homage to Sexy Hiking, a way more broken game. The story is pretty simple. You're Vin Diesel Stu and you're tasked with climbing over stuff.
Vin Diesel.
Or getting over stuff. That's it. That's the thing. All you have is this hammer to swing, and it seems simple, right? Wrong. This mechanic, while simple in a game world, is utterly, mind-blowingly complicated. I spent an entire day scratching my head over this, consulting drawings like some sort of Renaissance scientist who drunk too much mercury because...
that hits too close to home. Come on, because Renaissance scientists really sometimes does drink mercury. Yeah, the more you know.
Well, the physics of this game are unbelievably complex. You know what's amazing? 6 simple concepts utterly changed the entire workhorse of human technology. The wheel and axle, the pulley, the inclined freaking plane, the wedge, the lever, and the screw. Known as the 6 simple machines, these 6 different concepts could be applied either independently or together to create things capable of doing, well, just about anything.
Just about anything in the real world in which we experience on a daily basis. So yeah, the invention of the discovery of the 6 simple machines really does help humans becomes, modern society. So yay! And let's continue.
Transforming forces, these things are still in use today. And as you may have guessed, the one we're picking today is the lever. Levers are one of the most incredible machines, and when properly applied, kind of makes you feel like you're cheating the universe. With a long enough lever, a 50-kilogram person can lift a 100-kilogram person no problem, even if they weren't ordinarily capable of lifting them just by hoisting them aloft. And believe it or not, when you use a lever to lift something, even though it may seem easier to you, you're actually doing just as much work as if you were just deadlifting them. But how? Well, let's look at this simple lever here.
Because there's the length difference. The distance difference.
Class 1 lever. Just a beam over a fulcrum, like a seesaw. Now you have 100 kilo on the right and 50 kilo on the left. What happens? The 100 kilo person moves down and the 50 kilo person rises up into the air. Since all things being equal, the force of a 100 kilo person is much higher. But what if, say, you were going to move the fulcrum over to the right until it were, say, 1 meter away from the 100 kilo person and 2 meters away from the 50 kilo person? The opposite would happen. Magic? Nope! But why? Because of distance. Now, many people, when trying to describe why levers work, make this huge mistake of making it sound like the reason levers work is because the force of the lever is transferred across the longer section of the lever, which is why somehow it works. But that's not it. It's
somehow it works, science.
Actually the distance the objects move at the very ends of the lever that makes a difference. All right, so here's how it goes. At the fulcrum, when the lever moves, on both sides, it changes by the same angle. And using our good old Pythagorean theorem, we know that on the longer side, the 2-meter side, the distance the lever moves down on the 50 kilo side is actually twice as far as how high the 100 kilo side moves up. So if you push the 50 kilo side down half a meter, the 100 kilo person is going to rise only 1/4 of a meter. And this is how the magic happens.
The sweet old Pythagoras Theorem. Yeah! So a square plus b square equals to c square.
By spreading out the force over a longer distance, you are still inputting the same amount of energy, which is force over a distance. In order to move an object, you must always use the same amount of energy, which is force times distance.
Yes, W equals to F times force times distance. Yeah. Oh my god, I just remember. Yes.
Therefore, you can use less force if you increase the distance over which you apply that force. And that is the magical science of levers. You're gonna do the same amount of work, but you're doing it for longer, which, when you're dealing with force output limitations, like, say, with muscles, which have built-in limitations due to the nature of aerobic and anaerobic respiration.
Wow! Aerobic, so yeah, aerobic and anaerobic limitations on the human body. The more you know, so yeah. Literally the science of
Reducing the force needed makes things feel easier, even though, for the most part, as far as the universe is concerned, the checkbook of energy remains balanced. This is why Archimedes reportedly said that he could move the Earth if he had a long enough lever. Never mind the thing would need to be 10 million light years long in order to make a noticeable difference. All levers take advantage of this principle.
Yeah, there is the standard first class lever, second class lever, third class lever.
Lengthen the distance you apply the force in order to require less of it. There are 3 classes of levers with fulcrums in different places, and, well, I could get into all of them, but who cares? They don't apply here, because, well, at first it kind of looks like the dude in Getting Over It is using levers to his advantage. This could not be further from the truth. But first, we're gonna need hard numbers, which actually is kind of a pain in the butt to find. There's a lot of junk in Getting Over It, which is kind of the point of the whole thing, but when it comes to doing pixel measurements, these things are, well, they're not to scale, and most of them don't really exist in real life. But after hacking the gravity in the game so I could do some exploring, I found this, a red phone booth. Based on the London design, these things for a long time were all over the place. The most prolific of them being the K6 models, which were 2.51 meters high.
Oh, so the more you know. The K6 models of the telephone booth is 2.51 meters. The more you know.
Boom! Close enough for government work. Using this and the beauty of pixel measurements, I determined that the hammer Vin Diesel uses is 1.18 meters long, and he's capable of swinging it at a top speed of 9.3 meters per second. The real impressive stuff is when you look at how quickly he can rotate himself. Using some trigonometry, some sweet old pi r squared, we learned that he's capable of rotating himself at 2.5 meters per second from a dead stop. With
Wow, the good old pi r square. Yeah.
an acceleration of 11.55 meters per second squared, or 5.5 miles per hour and 25.8 miles per hour squared, respectively. Now, it took me a lot of experimentation, both in real life with some pencils that are now broken, and in the game to figure out exactly how he's raising himself off the ground with this damned hammer. And
too many broken pencils.
here's how it works. The outermost hand right here is the fulcrum. He pushes down on that, which confers force down the length of the hammer into the ground. Then, with the hand closer to him, he pulls up so he rotates around the other hand. With these mismatched forces, he's capable of lifting himself off the ground. Seems simple, right? Wrong!
Seems simple, right? Wrong.
I tried running this experiment myself with pencils, and I nearly broke my own fingers trying to get my hand to lift off the table. You can try it yourself if you want, but after a
You can try yourself. And mention if you want.
couple of hours messing around, I came up with an experiment. One water bottle filled with water with a wrench clamped to it to act as the hammer. Together, these things weigh 735 grams. Using this, I kid you not, a cast iron hook meant for hanging plants, I was able to perfectly mimic the application of forces from the game. And it took over 4.5 newtons in order to get the forces to balance out and achieve liftoff. No, that means nothing to you? Ha! Well, let me contextualize that. The 735 grams of the water bottle and the wrench, that, under the Earth's gravity, is 0.735 newtons.
That is like a huge percentage increase.
That means the force needed to lift them just barely was 612% higher. I had to apply 4,500 grams of force to raise 735 grams of water. Holy crap. But, oh, it gets so much worse. That is with an acceleration of 6.12 meters per second squared. In order to get the 11.55 meters per second squared from the game, I'd need 8.49 newtons, the equivalent of nearly 8.5 kilograms to lift something that's not even 3/4 of a kilogram. And that's
True. Using big amount of it's a bit how to say not inefficient, I guess. Not so productive. Yeah. Wow.
It's not even getting into lifting a freaking person. I weigh about 68 kilograms, and as a result, it would take over 786 kilograms of force in order to lift me this way. Or over 1,733 freaking pounds. Eddie Hall deadlifted 500 kilograms and holds the world record of all weightlifters. You know,
Wow, that achievement is awesome.
what that means? Even he could not lift me using this method, and even then, he'd never be able to lift himself because this dude weighs 186 kilograms, which means he'd need over 2,149 newtons of force to lift himself this way. That's over 5,000 pounds!
Not sure if you know this, right? This character over here, in Chinese, is called Li. Means strength, power, yeah, strong, something like that. And then the beasts.
We're
Oh, right, this is just the reverse of Li, yeah. This is just the reverse of Li.
talking about the weight of cars here. This all happens because the lever of getting over it is an inefficient as hell lever. Instead of lengthening the distance forces applied, it actually shortens it, since the fulcrum force and load lifted are so freaking close to one another and move over a comparatively short distance. This isn't a lever, it's an anti-lever. Nobody could lift themselves this way because it will always require more force than the person can actually conceivably output in order to pull it off. And that's not even taking into account the freaking cauldron. Heck, in order to get it to work even on a small scale, I had to use an actually efficient lever to apply the needed forces. Because otherwise, I was probably gonna break my own freaking bones from the huge Pascal forces being applied over such small surface areas. Yeah, enjoy those 810,000 freaking Pascals being applied to your hand bones, Diesel. I can practically hear your bones snapping as you try to lift yourself up, let alone from the near certain death you'd totally be experiencing from falling several feet with your legs crumpled up inside. What is that, a cast iron cauldron? Those legs are broken. This freaking game! Hours of my life I'll never get back proving the nonsense of this stuff. Think I'm wrong? Then prove me wrong. Lift yourself this way, Bennett Foddy, and I will personally apologize. Game's still fun, though. Sincerely, Austin.
Sincerely, Austin. And well, game's still fun though. Yeah. But he did mention that the bones will be broken, right? What if well, I mean, this is a game, right? What if instead of carbon life form, the player that we are playing as is not does not have calcium bones, instead have like super, I don't know what, vibranium bones or something like that. Yeah, so yay. Maybe there's a possibility.
Hey, thank you very much for watching my episode on Getting Over It.
Getting over it, yeah. Thank you so much for watching my video as well.
A weird choice, but the physics of it were too fascinating and too fun, and also headache-inducing, but also really a lot of fun to work out.
Headache-inducing.
Especially my little experiment there. Subscribe to the Game Theorists, and have a happy new year, mother truckers! See, I didn't actually swear there, YouTube. I said mother truckers. Because it's truckers who are parents. They drive. Alright, I'm gonna go now.
Okay. Ooh. Alright, thank you so much for watching this video. I hope that you will like this video as much as I do. It's really entertaining to watch and yeah, quite enjoyable. And if you do like my videos, please consider to like, share and subscribe to my channel and comment down below if you have anything to share with us. So yeah, remember it's like, share, subscribe, comment, follow, yeah, and I will see you next time. Thank you so much for watching this video. This video came out from your YouTube channel, Game Theorists. Do watch some of their other videos as well. And yeah, I will see you next time. But hey, that's just a theory, a game theory. Thanks for watching. Thank you. Subscribe. No, like seriously, please subscribe. Thank you so much. Thank you. Okay, and also this is the science of, so yeah. But hey, that's just a science of a science of. Thanks for watching.